Bombo Calorimeter. Bombo Calorimeter is suitable to determine the energy change in combustion. Heat release is transferred to both water and the metal parts of calorimeter. These are the water bath, so the heat release, this is where the combustion happened. The heat release will be transferred to water and the metal parts of the calorimeter. So all these metal parts, and these are the metal parts, the water, so the heat release will be transferred to both. Reaction or amount of heat released from the reaction is equal to negative mean heat release Q water plus Q calorimeter. Q water is equal to mass of water times specific heat capacity of water times the temperature change. So this is a Q water equation, and you also need to take account the Q calorimeter. So here it is. Heat released by a reaction is equal to heat absorbed by water and calorimeter. Calorimeter here is the metal parts of the calorimeter. So Q reaction negative because heat is released from the reaction, heat is released, equal to mass of water times specific heat capacity of water times the temperature change plus Q calorimeter is here the heat capacity of the calorimeter times the temperature change. So this is Q calorimeter. Heat capacity calorimeter times temperature change. However, some books include water as part of the calorimeter. So if the mass of water is not mentioned, you just use the equation Q reaction equals negative Q calorimeter. If the mass of water is not mentioned, just use this equation because you cannot substitute the Q water. We know that Q water is mass of water. Here, mass of water times the specific heat capacity of water. But if in the question, water is not mentioned or the mass of water is not mentioned, just use the equation Q reaction equals to negative Q calorimeter. So here, Q calorimeter is already include, the water is include in here. So just use this equation. Example, a quantity of 1.435 gram of naphthalene, a pungent smelling substance, this is naphthalene, used in moth repellents, was burned in Bombo calorimeter. So we know that this is combustion because we use Bombo calorimeter. Consequently, the temperature of water rose from 20.17 degrees Celsius to 25.84 degrees Celsius. So here you can calculate the temperature change. Here's the mass of the naphthalene. If the mass of water surrounding the calorimeter was exactly 2000 gram, mass of water is given, and the heat capacity of the Bombo calorimeter was 1.8 kilojoule per degree Celsius. So here, heat capacity of Bombo calorimeter per degree Celsius, so your temperature change, you don't need to change to Kelvin, because here it's per degree Celsius, you can just use degree Celsius straight away. So this is heat capacity of Bombo calorimeter, the capital letter C, heat capacity Bombo calorimeter, the capital letter C, 1.8 kilojoule per degree Celsius. We need to calculate the heat of combustion of naphthalene. Heat of combustion is the heat released by the reaction. So Q reaction. Heat combustion is the Q reaction. We need to calculate in kilojoule per mole. Make sure your answer must be for 1 mole because in kilojoule per mole. So now we have to calculate Q reaction. Q reaction is equal to negative. Here negative means the heat is released. Negative Q water. So here you include Q water because the mass of water is given. If the mass of water is not given, don't include Q water. So now Q water plus Q calorimeter, and then Q reaction equal to negative Q water. Formula is mass of water times specific heat capacity of water times the temperature change. So just substitute all the values, plus Q calorimeter is heat capacity of calorimeter times the temperature change. So given in the question, the heat capacity of calorimeter, and then you will get the answer of negative 5.76 times 10 to the power of 4 joule. This is not 1 mole yet. We don't know for how many mole. So your amount of heat released when the combustion process happen is 5.76 times 10 to the power of 4 joule. The question asks for 1 mole. For this one, we don't know for 1 mole. How many mole for this one? You have to calculate. We have the mass of the naphthalene. Mass divided by the molar mass, you will get the mole. So that one, the one that we got from previous slide, here, this amount of heat released from the combustion, is for 0.01121 mole of naphthalene. Because we use this gram of naphthalene, if you change to mole, you'll get 0.01121 mole. The question asks for 1 mole. You just compare 0.01121 mole releases about negative 5.76 times 10 to the power of 4 joule. If we need 1 mole, and then you have to cross multiply, you will get the answer of 5.14 times 10 to the power of 6 joule per mole. So this is the delta H. Make sure you write down delta H because the question asks for heat of combustion for kilojoule per mole for 1 mole. So you need to write down delta H. Negative means the heat is released. Include the negative heat is released. 5.14 times 10 to the power of 3 kilojoule per mole. Next example, combustion of 1.01 gram sucrose in a bomb calorimeter. Again, this is combustion process. Causes the temperature to rise from 24.92 degrees Celsius to 28.33 degrees Celsius. Heat capacity of calorimeter is given. We need to calculate the heat of combustion. Here, if you notice, the mass of water is not given. If the mass of water is not given at all, so the heat capacity of calorimeter here, the water heat is included in the heat capacity of the calorimeter. So just use the equation of Q reaction equals to negative Q calorimeter, means the water is included in here already. So just take the heat capacity of the calorimeter, 4.9 kilojoule per degree Celsius, times the temperature change, you will get negative 16.71 kilojoule. Okay, so here, this is the heat release for this mass. We want heat of combustion. The definition of heat of combustion is for 1 mole. Kilojoule per mole means for 1 mole. The one that we got here is not for 1 mole. We don't know for how many mole, but it's for 1.01 gram. If you want to know for how many mole, 16.71 kilojoule, you have to divide the mass divided by the molar mass. It's for 2.95 times 10 power of negative 3 mole. So this amount of heat released when you burn 2.95 times 10 power of negative 3 mole of C12H22O11. We need to calculate heat of combustion. Heat of combustion means you need for 1 mole. If this amount of mole release this amount of heat. If you need for 1 mole, it will release about negative 5664 kilojoule per mole.